Today's lesson is about solving inequalities. It is Common Core 9 through 12 Standard A.REI.3. We're going to learn all about inequalities in this lesson. So we need to know the four different types of inequalities: the less than or equal to, greater than, and greater than or equal to. Now let's look at a couple of simple examples just to make sure we understand, such as x is less than or equal to 5. Now this is already solved, so we know that x is any value less than or equal to 5, but graphically really helps us out to see exactly what that means. So if I draw a number line, the point that's really interesting that we must use is at 5. Now notice the dot is colored in. Why is it colored in? Because we have that equal to with our inequality. Now less than means any value smaller than 5 or to the left of 5. So any number 4, 3, negative 5, any number to the left of negative 5 is part of our solution set. Now another example would be x is greater than negative 2. So again, let's use a number line to illustrate this point. Now negative 2 is the important value, but you'll notice this time the circle is open because it's not equal to, it's not included. Now x is greater than negative 2, which is the inequality we have, means any value to the right of negative 2. So anything bigger than negative 2 is part of my solution set. Now let's look at an example that uses inequalities and let's solve it. First, let's look at an inequality without variables. Here's the situation. Lauren has $2. Raul has $3. So Lauren has less than Raul because 2 is less than 3. Now, that is true, and there's a lot of operations that we can do with inequalities that confuse people sometimes. So let's just go over the four options. Like the first thing we can do is we can add numbers to both sides. And you'll notice if you add 7, for instance, well, the result, the answer to that is still true. Just like 2 is less than 3, well, 9 is less than 10. Another thing that we can do is we can subtract numbers. So I'm going to subtract 2 from both sides and I get 0 is less than 1. Well, that's still true, just like 2 is less than 3. The third operation we can do with both sides is we can multiply both numbers by a positive number. So if we multiply both sides by 2, we're going to get 4 is less than 6. 4 is less than 6, just like 2 is less than 3. So if we add, subtract, or multiply by a positive number, everything works out. Now here's the thing we got to think about. What about if we multiply both sides by negative 3? Well, that's going to give us negative 6, and 3 times negative 3 is going to give us negative 9. Well, negative 6 is actually greater than negative 9. So in this case, to make the final statement true, I had to flip the inequality. So here's what you need to get out of this little example is add, subtract, multiply by a positive number, you're good, leave the inequality alone. But if you ever multiply or divide by a negative, you must flip the inequality. Let's solve the inequality, then we're going to graph the solution set. So on this one, 4x minus 2 is greater than or equal to negative 10. How do I solve this for x? Well, the first thing I have to do is anything added or subtracted on the side with x, we must get rid of it. We must do its opposite. And the opposite of subtracting 2 is to add 2 to both sides. Now on the left side, the 2's cancel off. So we get 4x is greater than or equal to, and negative 10 plus 2 is negative 8. Notice I did not change the inequality because I did not multiply or divide by a negative. Now the next step is to solve for x. Well, what we're going to do on both sides is divide by 4. On the left side, they cancel off, so you're going to get x is greater than or equal to, and negative 8 divided by 4 is negative 2. Now, this is our solution, but what does that mean? What all numbers are included? Well, let's put it on a number line. Notice negative 2 is where I start, and the dot is solid because it is equal to. And x is greater than means it's any value to the right. Let's look at one more example. This time we have negative 3y is less than 42 plus 11y. Now we want to solve for y. The first thing I notice is we have y's on both sides. Now I like to bring all my variables to the left side of the equation or the inequality. So what I'm going to do first is I'm going to subtract 11y from both sides. Now on the right side, the plus 11y, the minus 11y, they cancel off. On the left side, negative 3y minus 11y will give you a total of negative 14y, and that's still less than 42. Now to solve for y, how do I do it? Well, the negative 14 is times y. So to get rid of the negative 14, or to divide it off, I'm going to divide both sides by negative 14. Now remember, anytime you multiply or divide by a negative, you must flip the inequality. So now we're going to get y is greater than, and 42 divided by negative 14 is negative 3. So do not forget, you multiply or divide by a negative, you must flip the inequality. So what does that mean on a number line? Well, on a number line, I'm going to circle negative 3. Notice it is not colored in because it is not included. And since it is y is greater than negative 3, that means it's any value to the right of negative 3.